So the P stands for parentheses. Okay. What does the E stand for? Yes.
Exponent. I raised my hand, Cassie.
Good job, Riley.
Okay. What does the M and the D stand for? Yes,
No, I
Cassie.
don't know.
No, you don't. Mohammed.
Multiplication. There's no point in saying this.
Next one is adding and subtracting.
No.
Got it for you.
Say what? Yeah.
Adding.
Adding and subtracting.
I thought you weren't gonna use a plus. See.
No, it's an and. That's my and sign.
Mohammed, you laugh. Why did you laugh? Makes sense.
Okay.
So, some things to talk about with these. Parentheses is underneath the umbrella of grouping symbols. They just use parentheses because that's the one you most commonly see.
Isn't there like a saying to this?
Yep. Please excuse my dear Aunt Sally. Okay. I just say PEMDAS. Yeah, that's how I remember it. Okay. Now parentheses are one of them. What's another type of grouping symbol that you may see in order of operations stuff? Yeah.
Order of operations. You might see plus.
No, like grouping symbols, like that are like parentheses. What's different kinds of grouping symbols? They would say what? No, those are exponents. What other type of grouping symbols that do the same thing that parentheses do? You know?
What do you mean? Do the same thing as parentheses?
Yeah, parentheses enclose an area or numbers so that you make them do them first, right? Are there any other grouping symbols that do the same thing?
I don't know.
No.
So it looks just like it.
Braces?
Yeah.
Oh.
Braces. What else? Yeah.
What is that? That looks like squiggles.
Brackets.
I don't know how to draw faces.
Oh, that's what they were called. I thought they were.
So you mean like? No, I thought they were
What
just
are the
computer
little
things.
squiggy things?
Braces.
Why do they look like that?
Because that's what they are. That's what they look like.
I just thought they were computer things.
No, these are braces. Okay, now one that is a grouping symbol, but we don't really think about it that way,
Oh, that line.
is if I have a line that's used as division, you know that is division, but it is kind of a type of grouping symbol because it's separating the numerator from the denominator, so that means I'm going to take 2 minus 3 together and 4 plus 5 together before I divide, which you would normally like divide first, but it acts like a grouping symbol in this sense. Okay, so if you ever see a fraction with stuff on the top, stuff on the bottom, then you do those separately, and then you divide them. Okay? Now, we talked about this yesterday, exponents. Oh. So like 7 to the third or something like that has that power value. Okay, remember that's the exponent tells you how many times you take the base to itself. Multiply. Okay?
21.
So here, multiplication and division, and addition and subtraction, there's one thing that you need to know for both, is that you need to do those operations from left to right. If you don't do it left to right, you could run into some problems.
It won't turn out like to me. It won't be right.
Say what?
It won't be right if you don't do it.
Correct. Now, every once in a while you may be lucky because of the certain numbers that you have. Like if it was all addition, then if you didn't do it left or right, you would still probably get the same answer because addition is commutative. So it can switch around. But if it's subtraction and addition, you will probably get it wrong. Okay? So, next page, looking at 5. There are common errors that we run into with order of operations that kids seem to do all the time. Okay? Now, the first two are talking about if looking at these, you want to just kind of run through them and think, oh, I see all this stuff. I'm just going to go from left to right because you have in your mind addition's left to right, so I'll start here and just work my way over because it does have addition and subtraction and multiplication, but you have to separate those two. So you have to look for the multiplication first and then do that. So like here, for this first one, most kids would say, oh, 16 and 4, that's 20. 3 minus 1, that's 2. Okay? And then they would get 40, which is not a correct answer. What you need to do is start with those parentheses, right? You get the 2, so that part's correct.
So if you want to write that, take those like that.
Yeah, they're in that box.
No, like
Yeah, write those and cross out so you know that that's not. What?
What's on the
On the top?
But why do we?
Why did I write one? Got it? Okay. So, now, what's the next step? 4 times 2. Which is 8. Okay? So 16 plus 8 is going to be 24. Okay? So then that's the correct answer. Notice how the difference is that we would have gotten 40 over here, but 24, quite a difference in an answer. Okay? Same thing, if you see it all the way across, and some kids would start with a 5 plus 3 and get 8. And then the 8 minus 2 would do 6. Then multiply 6 times 9. And then try to divide 7 by 54. It goes into it 7 times. Leaves you with 5/7. So then that would be their answer. But that is incorrect. Okay? So, what you need to avoid is just saying, oh, this everything is right there. You got to break it up. So are there any parentheses? No. Are there any exponents?
No.
Are there any multiplication or division signs? Yeah. Yes. Okay. So then we'll start with the leftmost one, which is what?
Division 9
Multiplication.
2 times 9.
2 times 9 is the most left one, right?
Yeah.
Okay. So we'll start there. So 5 plus 3 minus, what's that going to be? 18. Okay? Right? Then, I would do what? 18 divided by 7. Now still, these don't go into each other perfectly. So how many times does 7 go into 18? 2. So, I'd get 2, and then, what's my remainder there? Or the fraction that's left over? 4. So that would be 4/7. Right? Okay. Then 5 plus 3 would be 8. Because now all we have is addition and subtraction left. Not quite. 6 and what? Nope. So remember, these are attached to each other. So I have 2 and I have 4/7, so there's like an addition sign there. So you have to think about this one as a 3. Okay? So then 8 minus 3 is what? 5. Okay? Then forget that that's 3 and worry about your 4/7. So 1, if I have one whole pizza, I'm cutting it into 7ths. I take 4/7 out and eat it all. What's left? 3 sevenths. Okay? So that'll be my fraction. Right? Okay? Now you can do that with any mixed numbers. Just round up to the next biggest number and then subtract or add, whatever you got to do, and then deal with the fraction next. Okay? So that would be my answer. Okay? There we go. Okay? Now, some other misconceptions with exponents is if I have 4 to the second power, some kids, and generally this is most kids, think that, and you're thinking in the right sense, so it's not like you're completely off. You're thinking, okay, 4 squared, I have to multiply somewhere. You might forget where. So then you think, oh, 4 times 2 gives me 8, so it must be 8. Okay? Which is incorrect. Yes. Because like we said when we were defining, that squared tells you how many 4s, or that base number is, and you multiply it to itself. So, 4 times 4 gives me 16. That would be the correct value. Okay? Okay?
We go to that other one?
Go back.
Yes.
Like that.
Yeah.
Now, here, how would you go about negative 3 squared? The way it's written. So what?
Negative 3 times negative 3. I mean, no, yeah.
Okay. Now, that's the misconception right there. And a lot of kids do it. Okay? They think that because there's a square, it goes to the entire thing. Okay? When in reality, it does not. Okay? The only time that would do that is like this example, where there's parentheses around the square. What actually happens, and if you plug in your calculator just as this is, it will get negative 9, because this is what it reads. It'll think negative 1 times 3 squared. Because in reality, we talked about this in our notes the other day, or yesterday. I gave you something like that and asked you what the exponents were. The obvious one is 5, right? But what is 4's exponent? 1. Good. You remember. Okay? Notice how those two things are separate. Okay? They don't have the same exponent. So the same thing here with this negative 3. There's a 3 here that's got a 2 as an exponent. And that negative sign is not attached. It has its own exponent of 1. Okay? But if there are parentheses around the negative 3, like this bottom one, then this thought process is correct. Okay? So then this one should say negative 1 times 9 is negative 9. Oh, just need time. As it loses connection or something fun like that. That's why, unfortunately. Okay? Any questions on those? Okay, so 56. Okay. 56. Now, what I'm going to give you now is that homework that I forgot to give out yesterday.
We gave us that other homework.
Yep. What? We didn't have homework because I forgot to give it to you, remember?
The other one.
To add the words into math? Yeah, we handed that in yesterday.
I handed it in, right?
Yeah.
Did you?
Yeah, because when you fell over the desk.
Oh, yeah.
Do we do that homework too?
No.